Now let us have the problem number 3 as what is the 15th term of the given sequence 11, 31, 59, 95, 139, 191, and 251. Again, we're going to rewrite the problem in this way as 11, 31, 59, 95, 139, 191, 251, and we are so concerned with the 15th term of the sequence. We're going to apply the common ratio or common difference. So common ratio, it cannot be here. So let's move with the common difference. And this is 20, 28, 36. This is 44. This is 52 and 60. Go further. We have 8, 8, 8, and so on. We have 8. It means that this sequence has a formula. Now, we know that a sub 1 is 11 and the last term is 15. Okay, so start with the a sub n. We know that a sub 1, a sub 2, a sub 3, to a sub 4. And we have those numbers as 11, 31, 59, 95 respectively. You don't know when to start, don't worry, just put in here 1, 2, 3, 4. Now evaluate the problem. It increased so huge, and so addition is not appropriate to apply here, but rather the multiplication. Now think first. We have 8 here, so factors are 8 times 1. We have also 4 times 2, and 2 times 4 are 1 times 8. Now if we're going to apply 8, 1 times 8, 8, add 3 to 11, 2 times 8 is 16, add 15, 3 times 8, 24, add 25, and 4 times 8 is 32, add to 63 to make it 95. However, when you're going to use the 4 as one of the factor here, try to imagine a number next to 11 is 12, and that is a factor of 4. So therefore, we're going to try 4. 31, another add by 1 is 32 as multiples of 4. So it's also possible. 60 is also possible. 95 is 96 is also divisible by 4. Then, since we have the multiplication, and if you're going to add it, still it has a huge number requirement. So we're going to again multiply it. We know 1 times 4 is 4, and we are reaching 12, so we're going to multiply it by 3. That is 12. To make it 11, subtract it by 1. 2 times 4 is 8. To make it 32, you should multiply it by 4, then minus 1. 3 times 4 is 12. To make it 60, you're going to multiply it by 5, then minus 1. 4 times 4 is 16. To make it 96, you're going to multiply it by 6 to make it 96, then subtract it to 1 to make it 95. Therefore, we have now n times 4 times, we don't know yet what would be the number here, but all of this shows consistency. So therefore, we have another row. Focus your eyes on this column, and n times 4 the same as 4n times, okay, and then let us put all in the parentheses because we don't know yet, n minus 1. If you don't know the number, start with the n. We have 1, 2, 3, 4. Then evaluate. What will you do to 1 to make it 3? Probably you're going to multiply by 3 or add by 2. How about 2? You're going to add by 2 or multiply it by 2. How about 5? You're going to add by 2 and multiplication is not possible. And then 4, you're going to add by 1. Therefore, it shows that what you're going to do is to add 2 for the rest of the number inside this parenthesis. So therefore, we have 4n times parenthesis. All of these are n plus 2 minus 1. Therefore, this would be our formula for problem number 3. And we need to verify whether our answer is right or wrong. Let's say sub 1, 2, 3, 4, 5, 6. Let's say we're going to compute for the sixth term. So A6 equals 4 times 6 substitution times 6 plus 2 minus 1. The answer must be 191. We know this is 24 and this is 8 minus 1. By calculator, so 24 times 8 is 192 minus 1. Then definitely A of the 6 terms is 191. It means our formula is correct. Therefore, if we're asked to solve for the 15th term, then by substitution, okay, 15 plus 2 minus 1. 4 times 15 is 60. 15 plus 2 is 17. Then by calculator, 60 times 17 is 1020. So we have here 1020 minus 1. Therefore, the fifth term for this sequence is 1019. That's the final answer. Let us have now problem number 4. What is the 12th term of the given sequence? 318, 63, 180, 465, and 1134. As our step, we're going to rewrite it in this way. 3, 18, 63, 180, 465. And we are so concerned with the 12th term. Now, if we are going to apply the common ratio, 3 times 6 is 18, but 18 times 6 is not possible here as long as the same as if we're going to use the common difference. So, in short, we're going to start right away our steps. A sub 1, A sub 2, A sub 3, and A sub 4. And we have those numbers as 3, 18, 63, and 180. Observe those numbers, they increase rapidly. So if that's so, multiplication method is best to use in this problem. And we know that n should be the 1, 2, 3, and 4 multiply to a number to make it 3. Obviously, that is 3. And since we're going to do the multiplication this way because the number increased rapidly, so 1 times 3 is 3. We should times it by 1. This is 6. And therefore 3, 9, this is 7. 180, 12, it should be 15. So therefore we have no consistency here. And times 3 times, we don't know yet. So let's do the same process in this case. So we have now copy paste. N times 3 is the same as 3n. Then parenthesis. Do it to the next rows. Okay. Now our case here is we don't know the number, we put it n. So 1, 2, 3, 4. Let's do the analysis in this portion. Okay, so after the n, you should subtract it by 1. So n, so become 1 minus 1, and 2 minus 1, 3 minus 1, and 4 minus 1. Now, focus our attention on this column. So after that, 1 minus 1 is 0, it's not 1, so probably you're going to multiply it or you're going to add it by 1. And so, it's not possible to multiply it by 1 here. Here, 2 minus 1 is 1, then you're going to multiply it to make it 3, so 3. 3 minus 1 is 2, and there's no number that you can multiply to 2 to make it 7, so this is not the right equation for that. So let's try to do the squaring. Okay, let's say n minus 1 square. So we have 1 minus 1 square, 2 minus 1 square, 3 minus 1 square, and 4 minus 1 square. 1 minus 1 is 0, so probably you're going to add plus 1 to make it 1. 2 minus 1 is 4. 2 minus 1 is 1. Then probably you're going to add by 2. 3 minus 1 is 2 square, 4, you're going to 3. 4 minus 1 is 3. Then 9, you're going to probably add by 6. But seems that it has no consistency at all, so therefore it's still wrong, and therefore we're going to sort out. Then let's say remove the squaring, then let's go back to n minus 1 times n. 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1 times n. 1, 2, 3, 4. Then let's do evaluation. Okay, so 1 minus 1 is 0 times 1. Then still, it has no solution. And therefore, our next resort is we're going back to the n minus 1 instead of n. So we're going back to n because it seems that it will never give the right factors for this. So let's go back with the 2n. And we know n 2 times 1. We have 2 times 2. We have 2 times 3 and 2 times 4. Then since that is 2, that is not 1, so we're going to subtract everything by 1. Okay, so minus 1. 2 times 1 is 1, minus 1 is 1. Okay, correct. But 2 times 2 is 4, minus 1 is 3, correct. 2 times 3 minus 1 is 5, it's not 7. And 2 times 4 is 8 minus 1 is not 15. Now, look at those numbers. What if we're going to raise the n as the power of 2? So, let's try. We have here 2 to the power of n. Now, let's have 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 2 to the power of 3 is 8. And 2 to the power of 4 is 16. And if we're going to subtract by 1, minus 1, minus 1, minus 1, and definitely 2 to the power of 1 minus 1 is 1. 2 to the power of 2, 4 minus 1 is 3. 2 to the power of 3 is 8. Minus 1, 7. 2 to the power of 16 minus 1, 15. It gives this column. Therefore, our formula here is 2n minus 1. And this is 2 to the power of 1, 2 to the power of 2, 2 to the power of 2, 2 to the power of 3, and 2 to the power of minus 1, minus 1, minus 1, minus 1. And it shows consistency. So, therefore, we have here 3n times 2 to the power of n minus 1. Let's do the verification. Verify. So let's say this is the first term, second, third, fourth, fifth. We have 6. We have a 6. So let's try to verify it. A 6 using the formula as 3 times 6. 2 to the power of 6 minus 1. And this is 18. 2 to the power of 6 is 64 minus 1. It should be 63. And 18 times 63 is 1134. That is the final answer. Therefore, if we're asked to solve for the 12th term, we have 3 times 12 times 12, times 2 to the power of 12 minus 1 equals 36. And 2 to the power of 12 is 4096. 4096 minus 1 is 36 times 4095. Going to multiply 36 times 4095. So A sub n equals 147,420. That is how we solve problem number 4.
Thank you and God bless everyone.